This is lesson 6.6, Solving Radical Inequalities, day 2. To solve a radical inequality, it will be similar to solving a radical equation in some regards, but different in others. If the index is even, which all of ours will be square roots, so it will be even, we have to identify the values of the variable for which the radicand is non-negative. That's because we can't take an even root of a negative. That's going to play into our solution. We'll then solve the inequality algebraically and then compare the values that make the inequality radicand be positive with our solution and kind of combine those two. So let me show you what I mean. So in number 1, we have a square root, and our radicand is 2x plus 3. So what I'm going to first do is find the values that make this a valid square root. We know we have to take the square root of a positive, so I'm setting 2x plus 3 greater than or equal to 0. And I'm going to subtract 3 from both sides, divide both sides by 2, and get x is greater than or equal to negative 3 halves. And that's giving us the values that make the radicand either 0 or a positive number for which it is defined. Now, I'm going to actually solve the inequality just like I solved equations. I'm going to isolate the square root of 2x plus 3 by adding 4 to both sides, which gives me 9 on the right. And now I'm going to square both sides. And on the left, I'm going to get 2x plus 3 is less than or equal to 81. I will subtract 3 from both sides. That's going to give me 2x is less than or equal to 78. And then I'll divide both sides by 2, which gives me x less than or equal to 39. So here's what I know. To be a valid solution, x has to be less than or equal to 39. That's on a continuum going towards negative infinity. At the same time, I know x has to be greater than or equal to negative 3 halves to be a valid square root in that inequality. So that's kind of like my stopping point. I cannot go beyond that or I'm going to get values that are invalid. So what I'm going to do is I'm going to combine this with my actual solution, and I'm going to say that negative 3 halves is less than or equal to x. I'm just flipping this inequality up here around so that x is on the right, and so that I can combine it and write it as a conjunction because this is the solution to the inequality. You see, to be valid, x has to be less than or equal to 39. Or to be a solution, x has to be less than or equal to 39. But to be valid, so that we're not taking the square root of a negative, x has to be greater than or equal to negative 3 halves. Both things have to be true, and we can write that in a compound form like you see. All right, let's try another. So number 2. This time, we have the square root of 7x minus 3 is greater than 2. And we are going to set 7x minus 3 greater than or equal to 0 to find those values that ensure we're not taking the square root of a negative. And that would be x greater than or equal to 3/7. Now I'm going to below solve my inequality. The good news here is my radical is already isolated. So I'm going to square both sides. I'm going to get 7x minus 3 is greater than 4. I'll add 3 to both sides to get 7x greater than 7, which means x is greater than 1. So now, here's what I know. To be a valid solution, x has to be greater than 1. Or to be a solution of the inequality, x has to be greater than 1. But to be a valid square root, x has to be greater than or equal to 3/7. The good news is 1 is already greater than 3/7, so that criteria is not going to affect my solution because 1 is already larger than 3/7. So my solution is just x greater than 1. All right, one final one. So this time I have two radicals, the square root of b plus 12 and the square root of b. So I'm going to test both of those. And if I set b plus 12 greater than or equal to 0, b has to be greater than or equal to negative 12. But the other radicand, b, would have to be greater than or equal to 0. And we want to go with the larger of these because that will ensure both radicands are valid and we're not taking the square root of a negative. If we use b greater than or equal to negative 12, the second radical would be negative. But using the larger value ensures they're both positive. Now I'm going to actually solve my inequality. I already have added the square root of b to both sides to isolate the square root of b plus 2. And like equations yesterday, I'm going to square both sides. That removes the radical on the left. On the right side, I either need to do FOIL or I need to use the shortcut. I'll use the shortcut, you choose. So when I square, I would get the square root of b is squared as b. That's the same thing as the first term in the product. And then for the middle term, if I take the product of the two terms, I get 2 times the square root of b, which is the outside and inside product. So I'm going to say plus 4 times the square root of b. And then I'm going to square the 2 and get 4. And of course, we learned yesterday, we've got to isolate our second radical now. And I canceled the b's, subtract 4 from both sides. I get 8 is greater than 4 times the square root of b. Divide both sides by 4. Get 2 greater than the square root of b. Square both sides. And that gives me 4 is greater than b, which is the same as saying b is less than 4. So now we've got to think about this. To be a valid solution, b has to be less than 4. But so we don't take the square root of a negative, b has to be greater than or equal to 0. So I do need to put those together. If I flip this around, we would say 0 is less than or equal to b, and I'm going to add that here, so that is the solution to this inequality. So inequalities take a little more thought because you do need to test and find what ensures you're not taking the square root of a negative and compare that to the actual solution of the inequality. And sometimes that alters the solution. In 1 and 3 it did, in 2 it did not. All right, hope that helps. Go ahead and look at Canvas for your assignment, and we'll see you next week. All right.